Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. This is another video in Engineers in Progress, particularly in uniform motion problems. I hope that the two exercises here can help you develop your thinking skills, especially in mathematical formulations. If you want to anticipate the solution to this problem, you may do so by pausing the video. So here is the first problem. Problem 67. A certain shopping mall has an escalator system. A shoplifter steps on the escalator at the rate of 2 steps per second, arrives at the top in 40 steps. Being caught lifting an item, the security manpower pursues the shoplifter and he steps down on the same escalator at the rate of 6 steps per second so that he will arrive at the bottom in 360 steps. How many steps has the escalator? So in this problem, take note that the escalator has also uh, an individual speed, its own speed, which is in steps per second also, and we will denote that by V. Then moving up, the speed would be V plus the speed of the shoplifter and multiplied by the time, then that would be equal to the number of steps, supposedly. So that is quantity V plus 2 times time going up is equal to the number of steps n. Then we are given the situation that when the shoplifters um, rises at the rate of 2 steps per second upward, he will arrive at the top in 40 steps. So that is 2 steps per second times time going up equals 40. Therefore, time in going up, because he will arrive at the top in 40 steps, is 20 seconds. Then we substitute it into this situation here. V plus 2 times 20 equals n, and we will call that equation 1. For the second situation, the shoplifter steps down on the same escalator, so it's opposing, and the speed in going down is greater in magnitude than the speed of the elevator in going up, because he will reach the bottom in 360 steps. So in the second situation, 6 minus v times time going down is equal to the number of steps also. And the time in going down can be computed because 6 steps per second times time in going down is equal to 360 steps. This is the number of steps that the shoplifter uh, underwent. So time in going down is equal to 60 seconds, and we substitute it into the same equation here. 6 minus v times 60 equals n. So equating the two, or dividing, so that we can cancel n. So v plus 20 over 6 minus v times 60 equals 1. So we can reduce 20 over 60 to 2 over 6. In fact, 1 over 3, but I just make it 2 over 6. So 2 times v, 2v plus 4 equals 6 times 6, 36 minus 6v. So 2v plus 4 equals 36 minus 6v. 2v plus 6v is 8v equals 36 minus 4, 32. Therefore, v is equal to 4 steps per second. This is the speed of the elevator in steps per second. So the number of steps, therefore, substitute into this equation here. Is v 4 plus 2, 6 times 20. So there are 120 steps in the escalator. So that's it for problem 67. For problem 68, a remote-controlled toy car traveling along a conveyor belt at the rate of 0.6 meters per second arrives at one end when its starting point on the conveyor is 30 meters behind it. In another situation, the toy car is controlled so that it travels along the conveyor belt at the rate of zero point 0.9 meter per second, arrives at the other end when its starting point has moved 65.625 meters. So how far apart are the ends of the belt conveyor? So in this situation, there are two situations. Take note that the conveyor itself has its own speed, which we do not know yet, and we'll call that V. So the net speed is equal to V plus, in the first situation, zero point 0.6 times time, we'll call that T1, equals supposedly the length or distance between the ends of the conveyor belt. So this is the starting point, and we have a point on the ends of the conveyor belt, and this is equal to quantity V plus zero point 0.6 T1 equals V plus zero point 0.9 T2. So this is for the first situation when the toy car arrives at the other end. The starting point will also move because the conveyor belt has also its own speed. So it reaches this point at the same time with the toy car has arrived on the other end. But it is mentioned that the starting point is 30 meters behind the toy car. So this is quantity V plus zero point 0.6 times T1, which is equal to quantity V plus zero point 0.9 in the second situation times T2. So this is the distance D, we'll call that D. And it is equal to quantity V plus zero point 0.6 times T1, or quantity V plus zero point 0.9 times T2. So this distance is the speed of the escalator, speed of the conveyor belt times T1 also. So this is the starting point, and the starting point arrives here due to the speed of the escalator, and that distance is V times T1. So from the figure, V times T1 plus 30 equals D. And in the second situation, the starting point when the toy car has a speed of zero point 0.9 meters per second, the starting point has moved a distance of 65.625, so that's 65.625 meters, and that is the speed of the conveyor belt times time T2. And this distance is the speed of the conveyor belt plus the speed of the toy car times T2. So that's why the toy car has reached the other end. So that's why we equate distance, this distance here, as V plus zero point 0.9 times T2. So D equals 30 plus VT1 from this figure here, 30 meters plus VT1. And it is also equal to V plus zero point 0.9 times T2. So VT2, which is 65.625 from this equation. So equating V plus zero point 0.6 T1 equals quantity V plus zero point 0.9 times T2. And T2 is 65.625 over V. And take note that VT1, V times T1, is the distance that the starting point has moved in the first situation. So T2 equals 65.625 over V, to be substituted here. And 30 plus VT1 is equal to V plus zero point 0.6 times T1 also. So expanding, because we can cancel out VT1 here, we have VT1 also in the right side. So 30 equals 0.6 T1. So 30 plus VT1 equals VT1 plus zero point 0.6 T1. We can cancel VT1. So that means T1 equals 30 over zero point 0.6. And 30 over zero point 0.6 is equal to 50 seconds. We then substitute into this equation the value of T1, which is 50, and T2, which is 65.625 over V, leaving V as the only unknown. So V plus zero point 0.6 times 50 equals quantity V plus zero point 0.9 times 65.625 over V. So distribute 50V plus 30 equals 65.625 plus zero point 0.9 of 65.625 over V. So that's 59.0625 over V. Simplifying, 50V minus 35.625 V minus 59.0625 over V equals 0. Multiply everything by V. So we have 50V square minus 35.625V minus 59.0625 equals 0. So this is a quadratic equation. Then using the quadratic formula and your calculator there, the positive value of V is equal to 1.5 meters per second. Having found the value of V, we can now compute the distance D, and that is equal to V times 50, 1.5 times 50 plus 30. So 1.5 plus, also 1.5 plus zero point 0.6 times T1, which is 50. It is also equal to V 1.5 times 50, 75 plus 30, so 105 meters. So that's the distance, or the distance between the ends of the conveyor belt. That's it for this video.